We've been asked if we heat 15.5 grams of ammonium chloride and we form nitrogen, hydrogen, and chlorine gases, what is the theoretical yield of hydrogen gas in grams? To do that, we're going to need two pieces of information. We're going to need to know how many moles of ammonium chloride there are compared to moles of hydrogen gas, because that's the only way we can go from one compound to another. Then, we're going to need to be able to go from grams of ammonium chloride to get into moles of ammonium chloride. And we're going to get that from the molar mass that has the units of grams per mole from the periodic table. We're also going to need to go from moles of hydrogen gas to grams of hydrogen gas. And again, we'll use the periodic table. Before I can find any molar masses or find my ratio of moles to moles, the moles to moles are going to be my coefficients in a balanced chemical equation. So we're going to have to write the balanced chemical equation. To do that, we're going to have to write the formula or formulas for our reactants. We're going to have to write the formulas for our products. And then we're going to balance the atoms or ions on both sides of the arrow. So our first one, ammonium chloride, is the one being heated. Ammonium is not a metal, even though it ends up with ium like all the other metals. It's one of the polyatomic ions you have to memorize is NH4+. Chloride is just going to be the symbol, Cl. It makes a -1 charge. You put those guys together, you make ammonium chloride. It's ionic, so it's a solid at room temperature. No, you would not need to put the S if you're just for this math calculation. I'm just teaching multiple things on this video. Heating, you would show with a triangle over an arrow. No, you wouldn't have to do that if it's a math problem, but why not learn how to do it right? Nitrogen gas. It's one of my super 7 diatomic elements, so it exists as N2. Hydrogen gas, same thing, exists as H2. Chlorine gas, diatomic Cl2. That's how those three gases, those three elements exist in nature. To balance it, we'll come back over here. There's one nitrogen on the left. Whoopsie, right there, one nitrogen. Over here, there's 2, so we slap a 2 in front of the NH4Cl. We have 2 times 4, 2 groups of 4 hydrogens, that's 8. So over in front of my H2, I need to put a 4. And in my 2 groups of NH4Cl, I have 2 chlorines. And when I come over here, I've got 2 chlorines already. We could read this as 2 moles of NH4Cl forms, there's an invisible 1 there, 1 mole of nitrogen gas, 4 moles of hydrogen gas, and 1 mole of chlorine gas. That's where we're going to be able to go from our moles of one compound to moles of another compound. So let's set it up. We're starting out with ammonium chloride. They told us we had 15.5 grams. So that's where we start. Now we play a game where we go from drawing times in a line. Whatever unit is up here needs to go to the bottom down here. So grams NH4Cl. The only thing I can convert grams of NH4Cl into is moles of NH4Cl. That unit now needs to go on the bottom of the next one because we are trying to get to grams of hydrogen gas. To do that, I go from moles of ammonium chloride to moles of H2. Lastly, if I want grams of H2, I need to take that unit that I don't want anymore, put it on the bottom, and put the grams of H2 that I go into. Notice we didn't go backwards. Once we were in moles of NH4Cl, there was no point to go back to grams of that. And once we were in moles of H2, there was no point in going back to moles of NH4Cl. So keep your goal in mind. These numbers that you're seeing with it, they're coming from the fact that whenever you're going from grams to moles, it's always going to be a 1 for your moles. Do not put the number from the coefficients in the balanced equation there. It's going to screw you up. It's always grams per 1 mole. And we're getting that from the periodic table. For NH4Cl, you would take the fact that there's one nitrogen, multiply it by the grams per mole, the molar mass of nitrogen. It would be 14.01. The 4 hydrogens in ammonium chloride times their molar mass, we have 4.032 grams per mole for the 4 hydrogens. The 1 chlorine from the formula, multiply it by the molar mass of chlorine, you get that, you add them together. We used 4 significant figures. We could have had just 3 because the starting number 15.5 has 3 significant figures. You could also keep all 4 or 5 or 6 that you have on your periodic table all the way through the problem and just round to 3 sig figs at the end. To get our grams of NH4Cl, we're going to put in that 53.49 that we just calculated. That's coming from the molar mass on the periodic table. To get from moles of NH4Cl to moles of H2, we're using our coefficients from our balanced equation. We had said that there was 2 moles of NH4Cl will form 4 moles of H2. So that's where those go, right there. Lastly, we need the molar mass from the periodic table for hydrogen gas. There's 2 atoms of hydrogen. The molar mass of hydrogen is 1.008, and so we take that, and it's 2.016 grams per mole for hydrogen gas. It's going to be 1 mole because it's going from grams to moles. It's always 1 mole. You want to multiply across the top, 15.5, don't really need to multiply by 1, times 4, times 2.016, divide by anybody on the bottom, divide by 53.49, divide by 2, don't really need to divide by 1, and your answer should be something similar to 1.17 grams of H2. That's your theoretical yield of hydrogen gas in grams. If you got 1.16, that's okay. 1.18, you can change the last digit by 1 or 2 numbers and it's still basically the same. Now just for fun, I asked if experimentally we got 0.089 grams of hydrogen gas, what is the percent yield? To do that, you take what you actually got, divide that, the same units on the bottom, with what we had for our theoretical yield. That comes out to 0.76. Multiply it by 100%. This person had a 76% yield for this reaction. You can only find percent yield if someone tells you what you got experimentally. You need to know your actual yield. But the theoretical yield you calculate following the steps we just showed.